All right, AGS1. Today we are talking about 5.6, more or less. So today we're not talking about Carlos and Clarita. We're talking just about straight inequalities and how to graph them, and how to graph multiple inequalities on the same graph. Before we get to multiple inequalities on the same graph, I thought I'd start with a few example problems that all have the same numbers involved, but the alligators, the inequalities, start switching around and how that affects the picture, the graph. The first thing I notice about this inequality is that it's in slope-intercept form, that this is the slope and this is the y-intercept. So I know that on my graph, if I were to just pretend this is like an equals sign, that I would put a hard dot on -4. 1, 2, 3, 4. And then the slope here, the rise over run, is that it goes up 1 over 2, over to the right 2. So it goes up 1 over 2. Like the little slope triangle, if I were to get real in here, is up 1 and then over 2. That's the slope, is m is equal to 1 over 2. So then I can keep going up 1 over 2, up 1 over 2, up 1 over 2. So it crosses the x-axis here. And then let's see if I can get a line that goes through all of these. There we go. Cool. Now, oh, I've already made a mistake. You guys, based off of this symbol right here, in general, if it's a less than or greater than, this is going to be a dotted line. Rather than if this was an equal sign, you would make it a solid line. So here I'm going to change up my, there we go, dash, dotted, however you want to say that. So we go through these points. There, perfect. So now that's what it would look like if it were just a straight line with an equal sign, but it, dashed instead of solid. The only other thing we need to do is to decide which side to shade on. Now, I've been showing my students the method where you can pick any point and plug it into the inequality and see if you get a true or a false inequality. So let's do that real quick, and then I'll talk about the easier way to do that. Like if I pick the point 0, 0, let's get back to my regular, there we go. And then I plug that into the main inequality. That means 0 is less than negative, or positive 1/2 times 0 minus 4, which is 0 is less than -4. So then you have to think, is this true or is this false? Is 0 less than -4? This is false. 0 is not less than -4. It's greater than -4. So that means that we would shade where that point does, on the other side of where that point lives. So 0, 0 lives on this side. So we're not going to shade that side. We're going to shade underneath the line. Oops. So that's what this graph would look like. The shortcut I want to show you guys is that this symbol right here, if your inequality is set up such that the y is on the left, it's like, y is less than, something x plus something, then in general, if it's a less than symbol, you're going to shade underneath the line. So let's put a little note about that. This is underneath. But if it's ever confusing to you about what underneath means, just pick a point and test it. Remember, any point that's down here, like if I choose this point, and whatever this is, 1, 2, 3, 4, -1, 2, 3, 4, 5. So 4, -5, that should work in the original inequality. It'll give you a true inequality. Any point that's in that shaded zone. Now, you guys, the next one is the exact same numbers, but the only thing that's different is this symbol has flipped. It's now a greater than. So it's still going to cross, get my dashed, it's still going to cross at -4. 1, 2, 3, 4, because that's the intercept. And then it goes up 1 over 2, 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 up 1 over 2. So Because it's just a less than or greater than, we're going to use a dashed line that goes through those points. The only thing that's going to be different about this one is the shading. Because the y is on the right, we can use the rule of saying that because this is greater than, this is going to mean shade above the line. So you could test a point, like you could plug in 0, 0, and 0, 0, because it lives right here, will produce a true inequality. But here we're just going to shade above the line. Now the next two problems are still all the same numbers, but the only thing that's changed is now this is a less than or equal to. If you have a less than or equal to, this is going to be a solid line instead of a dashed. So up here, because it was just a regular less than, that means you used a dashed line. Here, the less than or equal to means it's solid. What this means is that any point that's actually directly on the line is also going to be included in our solution set. So I would still say that it crosses at -4, and then it goes up 1 over 2, up 1 over 2, up 1 over 2, up 1 over 2. Get a line that goes through there. Now, you guys, because this is a less than, that means that we shade under. So this would be all the way underneath the line. The next one is still all the same numbers, but now it's a greater than or equal to. The or equal to means solid line. So graph it like normal. Still crosses at -4. Still goes up 1 over 2, up 1 over 2, up 1 over 2. Get a line that goes through there. Whoops, messed that one up. Yeah, that goes through. But now, because it's a greater than, that means that we are going to shade above. So, 4 different versions of the same line, but if it's a less than or greater than, then it's a dashed line. And then if it's less than, you go under. If it's greater than, you go above. If it's or equal to, it's a solid line. But still, if it's less than, you go under. If it's greater than, you go above. The next one is solve the following system. So the system means usually, until you get into like later classes, this is going to be 2 equations, or 2 inequalities, I guess. 2 inequalities, 2 unknowns, 2 variables. Okay, here's the plan. We're going to, because they're in the form of ax plus by is less than or equal to something, I think we should just find the x and y intercepts rather than putting it into slope intercept form. Let's just find the 2 intercepts and then connect them with a straight line. So for 5x plus 4y, and we can just pretend it's equal to 40, the x-intercept is when you make y 0. So this would be 5x plus 4 times 0 is equal to 40. So then when you solve that, you get x is equal to 8, which means that the x-intercept is 8, 0. The y-intercept is when you make x 0. So put in a 0 for x, you get 4y, not x, is equal to 40. So when you solve this, y is equal to 10, which means 0, 10 is the intercept for that one. So that was for this guy here. Now let's do the same thing, but for this one over here. So we'll say this is 6x minus 8y is equal to 24. And then the x-intercept, you're going to make y 0. And then when you solve that, you get x is equal to 4. So this is 4 comma 0. And then the y-intercept is make x 0. Good thing all these numbers divide evenly, huh? It's almost like I designed it like that. So y-intercept is 0 comma negative 3. Oh boy. Okay, so we're going to keep track of these probably with 2 different colors is how we're going to do this. Okay, so for the first one, it's 8, 0, and 0, 10. Let's go orange for the first one. 8, 0, and 0, 10. So 1, 2, 3, 4, 5, 6, 7, 8. So this is the point 8, 0, and then 0, 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So this is 0, 10. And then I need to connect these with a straight line. Now, is it going to be dashed or solid? See how this symbol right here is an or equal to? That means that we are going to put a solid line between these two. And then, because it's a less than here, again, that means that we shade underneath the line. So look, we're going to have to get our orange shading and go... There we go. So that was the first inequality. 5x plus 4y is less than or equal to 40. I guess I could be a good math teacher and label it. That this one is 5x plus 4y is less than or equal to 40. Is that what I did? Yeah. The next one, the x-intercept is 4, 0, and the y-intercept is 0, negative 3. So let's go green. 4, 0, and 0, negative 3. So 1, 2, 3, here's 4. And then negative 3. 0, negative 3 is right here. Now, because this symbol is not an or equal to, that means I'm going to have to switch to my dashed line that goes through these. So let's see. So that one is 6x minus 8y is less than 24. So 6x minus 8y is less than 24. But the one thing I haven't done yet is decided which side to shade of that dashed line. The symbol right here, let's use a green highlighter, is a less than, which means that I'm going to shade underneath. Nope, sorry. You guys, I totally goofed this up. Yes, it worked to shade underneath with this one, but you guys, what I meant to say with all of this is that the whole less than, greater than, underneath, above doesn't work when it's in this form, because I almost just shaded underneath this guy right here, which is actually not correct. So when it's in the ax plus by is equal to c form, pick a point and test it. I'm going to strongly recommend that. So if I pick the point 0, 0, and plug it into this right here, just a quick check to see which side to shade on. That means 6 times 0 minus 8 times 0 is less than 24. So is 0 less than 24? Yes, it is, which means that I shade above the line. Uh-oh, I almost shaded below. Okay. You guys, now that they're both properly shaded, also that pick a point thing would have worked with this guy as well. If you had picked 0, 0 and put it in, you would have gotten a true inequality, so you would shade where 0 lives, which happens to be underneath the orange line. Now, our answer is anything that's in this zone. So all of this, these points are your answers. Any point that lives in that zone should satisfy both inequalities. Next up, what system of inequalities would have this solution set? Well, let's think here. I notice that the dashed line that this crosses at 0, 4, and then goes, like if I look at just the slope, like you can count by whole numbers and say this goes down 2 over 2, or you could just even go smaller than that and say that this goes down 1 over 1. So that's down 1, so this is minus 1, and then over a plus 1. And then it goes down 1 over 1, down 1 over 1. So this would, if it were just an equation, would be y is equal to negative 1 over 1x, but we don't write 1 over 1. We just write a ghosty 1 out in front. And then the y-intercept is 4. But because it's a dashed line, that means it's going to be a less than or greater than. And please notice that it is shaded above this line, which means that that's going to be y is greater than negative x plus 4. So that's just for the dashed one. Now let's do the same thing for this line right here. If I think about slope-intercept form, this guy crosses at 0, 0. Now let's look at the slope triangles. It goes up 1 to the right 2. And then it goes up 1 to the right 2. So that slope is going to be 1 over 2, 1/2. So if I were to just write this as an equation, it would be y is equal to 1/2 x plus 0. But you don't need to do the plus 0 part. You can just write y is equal to 1/2 x. Now that's pretending that it's an actual line, but there's shading involved. It's shaded above this line. So that means that this is going to be a greater than as well. So this is going to be y is greater than or equal to 1/2 x. The or equal to is because this is a solid line, as opposed to the dashed line right here, which gets just a greater than, not a greater than or equal to. So the system final answers would be y is greater than or equal to 1/2 x and y is greater than negative x plus 4. Okay, you guys, that is all I have for you for the day. The formative is very similar. It's all shading, all inequalities, all